And welcome back to Van-Gelder Tutoring. Today we're going to be looking at relative mass part 3, where we're going to be looking at relative molecular mass, relative formula mass, as well as some practice questions. So, to start off with, what is relative formula mass? Now, relative formula mass is the average mass of a formula unit compared to 1/12 of the mass of carbon-12. So what this means is similar to what we covered in the previous videos, that carbon has a mass of 12 and we compare everything to 1/12 of that, which would be 1. And relative formula mass is used specifically for ionic compounds, so for example sodium chloride and magnesium chloride. Now, to calculate the relative formula mass of a compound, we simply add together relative atomic masses of all the ions in a formula. So for example, calculate the relative formula mass of potassium nitrate, which is KNO3. So what we need to do is find each of those elements on the periodic table. So we'll start off with potassium, which is K. Now, if we have a look on the periodic table, we can see that potassium has a mass of 39.1. Moving on from there, we can go on to nitrogen, and we can see that nitrogen has a mass of 14. And lastly, we can look at oxygen. Now, oxygen in this formula is O3, so we're going to have 3 of them. So oxygen itself has a mass of 16, with 3 of them that would make a 48. And then lastly, we're going to add all these masses together, and that gives us a total mass of 101.1. So the relative formula mass for potassium nitrate is 101.1. So this is where we start off with our practice questions. The practice questions cover things from part 1 and part 2 of this series of videos. Please feel free to pause the video here, have a go at the question, and see how you do. And this is the second set of questions. So calculate the relative molecular mass of the following compounds. Again, pause the video here and have a go at answering these questions. So moving on to the answers for calculating relative atomic mass of the element shown. Of course, we're going to use the same formula that we covered in part 1 and part 2. We simply look at the relative percentage abundances, which on this graph can be a little tricky to see. So if you did have some difficulty reading off what the relative abundance was, don't be too harsh on yourself when you're marking. Now, of course, let's just look at one peak. Let's look at the peak at an MR of 90, mass to charge ratio of 90. It has a relative abundance of roughly 50, so we're going to do 90 times 50. And then we move on to the next peak at 91, which has an abundance of 10. So its mass to charge ratio, which is 91, multiplied by its abundance, which is 10. And we repeat this the whole way across. And lastly, we divide by 100, as we're working with relative abundance percentage as opposed to simply relative abundance. And we should have got an answer around 91.4. Again, if you were slightly off with your answers due to difficulty reading the graph, of course, reading a graph on screen is much harder than doing it with something that's printed out and in front of you. So as long as you constructed the equation correctly, if you had a few errors reading off, don't be too harsh on yourself with the marking. And secondly, here are the answers to the relative molecular masses of the compounds that were shown on screen. A few ions were thrown in there just to see if we could throw you off, particularly with the Cr2O7- and the Sr42-. Remember, being an ion does not change its mass. That's something the students trip upon with quite a lot. And otherwise, that covers our practice questions. Thank you again for watching Van-Gelder Tutoring's videos. If you'd like to support the channel and support me producing more videos in a way that is free to you, please drop a subscribe onto the channel and like this video. Thanks again for watching, and stay tuned for more.